Hello everybody, welcome to Video Notes 4.2. We're going to name and write formulas for ions and ionic compounds. And we're going to talk about metals that can form more than one charge. And talk about acids. So, ionic compounds. How do you even know you have an ionic compound? You're looking for a metal or ammonium, and then a non-metal or polyatomic ion. So, oh look, it's a metal and a non-metal. Boom, ionic compound. Okay? Now, all metal and polyatomic ion, boom, ionic compound. Ionic C. Okay, so we have a non-metal and a non-metal. Ruh-roh, this is covalent. Yeah. All right. Polyatomic ion, ionic. Non-metal. What the? Non-metal. This is covalent. And finally, non-metal, charge. This is even a compound, people. This is an ion. Happens to be polyatomic. Okay, so ionic compounds are metal ions or ammonium and non-metal ions or polyatomic anions, and the positives and negatives must balance. So if we have sodium sulfide, that's symbol for sodium, symbol for sulfide. Look at the table, we got a +1, we got a -2. So the formula is Na2S because you need 2 of the sodium for 1 of the sulfide to equal 0. Okay, balance is the key to life. So, how do we know charges? Some metals always have the same ionic charge. So group 1A, 2A, always have the same charge. And silver, zinc, and aluminum. Okay, and they always have the same charge because of electron configurations in the group they're in. So +1s, +2s, right? Hydrogen's out, and then aluminum, zinc, and silver, and it's a 3 +3 +2 +1 because of electron configs, and some nonmetals always have the same ionic charge. Okay, so we have group 7A, 6A, 5A, -1, -2, -3, all right? Why? Need full octets, all right? So memorize those, memorize them, all right? Do it, memorize them always. I call them the always ions, always positives, what you see, always negatives, what you see. Okay, so examples of writing ionic formulas: calcium bromide. Ca is +2. Bromide is a -1. How did I know? Periodic table. So I need, looks like I need 2 bromides in this compound and 1 calcium to equal 0. Negative, +2 equals 0. Aluminum, +3. Oxide, -2. How do I know? Periodic table. Okay, still not equal. Look, it's equal. So 2 aluminums and 3 oxides and aluminum oxide. So that's how you write the formulas. Formulas: cancel charge, make it equal. Cancel charge, make it equal 0. Okay. Writing names is the opposite. You take the name of the first thing. This is a metal and non-metal, so we call it potassium because that's its name. The first name stays the same. Second name, change to IDE if it's from the periodic table. Okay. Look, it's sodium. And then the second one is from the anions from there, so it's nitride. Okay. All right. Now, what if there's polyatomic ions in your compounds? That's why we memorize them. Look, sodium is a +1, acetate is C2, H3, O2 negative. Why? Because that's what it is. That's it. So then if we put them together, it's a 1 and a 1. That's its formula because +1 minus 1 equals 0. This is the identity of acetate, so we have to write it down. Magnesium sulfate. So magnesium is +2. How do we know? Periodic table. Sulfates, SO4 -2. How do I know? I memorized it. So I am going to do MgSO4 because +2 minus 2 equals 0, 1 of each. Aluminum sulfide, SO3 -2. Oh, kind of full. Aluminum's +6. All right, so it looks like I need some more sulfite. Uh-oh, now I need some more aluminum. Uh-oh, now I need some more sulfite. What is she doing? She's making it equal 0. Woohoo! So, we need 2 aluminums. And look at these parentheses. Sulfite is a whole thing. I can't change its identity. That's it. But I need 3 of those in my compound. Okay. You try ammonium carbonate. Do it. Now, writing the names. This is an ionic compound. We got a metal and a polyatomic ion. So I need to write the name of the metal, potassium. Potassium. I need to write the name of the polyatomic ion. Thank goodness I memorized cyanide. Woohoo! All right. Ionic compound, how do I know? Metal and polyatomic ion. So I write the name of the metal. Bam. And I write the name of the polyatomic ion. Hydroxide. And then I'm done. All right. Are there exceptions? Is it going to get tougher? Well, here's how you write the formulas for ionic compounds. You first recognize it. Then you write the charges and use enough ions to make sure positive equals negative and zeros over else. Use parentheses only to keep polyatomic ions together if there's more than one. And then the compound formula shows no charges because they equal 0. Okay. Writing names. Again, recognize metals are polyatomic ions. Write the name of the cation first, name of the anion second. Now we look for Roman metals. Now we haven't done any with Roman metals, so we're going to do it now. Here's a metal. Here's a nonmetal. So I write the name of the metal, aluminum. And then I write the name of the nonmetal, chlor with IDE, chloride, because it's right from the periodic table. Okay, done, because aluminum is always +3, so I don't need any other thing in the name. Okay, metal, polyatomic ion. So I write the name of the metal, sodium. And then I write the name of the polyatomic ion, oxalate. Thank goodness I memorized that. Sodium oxalate. So, do I need anything else in the name? No, because sodium is always +1. So I don't need any other thing. Now, here we got metal. Here we got a polyatomic ion. Name of the metal, iron. Name of the nonmetal, carbonate. Thank goodness I memorized that. Woohoo, carbonate. Now I gotta be careful. Find iron on the periodic table. It's not an always metal. It doesn't always have the same charge. So I have to tell you what the charge of iron is in this compound. So how do I figure that out? Well, this got put together to equal 0. And I can tell that there's 2 irons in it and 3 carbonates in it. Now, I know carbonate has a -2 charge because I memorized it. So that means this iron has to be a total of +6. So I know that it has to be a +3 and a +3. So in the name, I have to write the Roman numeral 3. I have to, because iron's not always a +3. So careful, careful for the not always. Okay. Let's try some more, or let's find out about Roman metals. When you see the name of a compound with a Roman metal, so that's a metal that's not always the same charge, you decide the charge the metal has in the name because it tells you. If you see the name, you'll see a Roman numeral. This is 1 +1 +2 +3 +4 +5 +6 +7 +8. Right? Oh, look, here's a name, iron 3 chloride. Know the symbol for iron is Fe. The symbol for chloride is Cl with a -1. But if I look on the periodic table, I can't find iron's charge, so I have to use this, +3. So I need 3 chlorides. So the formula is FeCl3. How do I know that iron's a +3? Because of this. Right? So that's what I did. Write the formula against the charge. If I see the formula, I have to figure out the charge by undoing the formula. Okay? So let's practice. Here's the name, copper oxide. Periodic table -2. I look for copper on the periodic table. I don't find the charge, so I have to use +2. So it's CuO. All right, this is copper. This is oxide. This time it's a +1. So I need 2 copper for an oxide. This copper is a +1. Potassium, K, nitrate, NO3, negative. I could look on the periodic table and find potassium's +1. So I don't need a Roman numeral because it's always a +1. Always +1 potassium. Lead 4 carbonate. So lead's Pb, carbonate Cl3 -2. What's the deal with lead? You might think, hey, lead's in the same group as, carbon, which says ±4. But I got to tell you, it's not an always metal, so you always have to put the charge, and so I know it's a +4, So now I got BB, 2 of those. You need 2 carbonates to make it equal 0. Okay, how to name them? Copper, metal, non-metal. So I need the name of copper. Copper. Need the name of Cl2. Well, not Cl2, but Cl. Chloride. And then I say to myself, self, where's copper? It's in the Roman. So I need a Roman numeral. So I take it apart. I got 2 chlorides. I got 1 copper. So I know copper must be a +2 charge. So I got to put it in parentheses. Okay. Let's do iron oxide. So this is a metal. This is a non-metal. How do I write the name? I write the name of the metal, iron. Name of the metal, oxide. And I say to myself, self, where is this on the periodic table? Roman. So I need to take it apart. Reaction, 2 iron. Each action is -2 because oxide is always -2. That means this is a +3 and that's a +3. So I got to put a Roman numeral. I have to. Yes, you have to. You have to. Because it's not an always. It's not an always the same. Okay, is there more? Yeah, I want you to try. You try. You try gold and cobalt nitrate. So let's do this one. This is a metal. This is a polyatomic ion. This is an ionic complex. I did the first one. And the second thing, nitrate. And I say to myself, self, where's aluminum? Look, aluminum's in always. So guess what? Do I need a Roman numeral? No, Roman. Because it's an always, so we're done. All right, lead, metal, carbonate, polyatomic ion. Write them down. Lead, carbonate. And I look on the periodic table and say to myself, does lead always have the same charge? No, so we need a Roman numeral. Carbonate, -2, and there's 2 of them. So that means with 1 lead, it has to be a +4. So I need an IV. I need an IV stat. Okay, next. Acids. Acids all have one thing in common, hydrogen. Usually the acidic hydrogen is placed in front of the compound. So when you see the H, it's saying to you, hello, 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 hello. I'm an acid. Hello. Hello. Acid. Okay. So here's how you name acids and write their formulas. Once you recognize, then to write their name, you find out what the second part of the acid is, the anion. Okay. If the anion ends in IDE, like chloride, then you have to put hydro in front of the name, ic acid at the end. So HCl, that ends in IDE, chloride. So I have to call it hydrochloric acid. H2S. This part ends in IDE, so I have to call it hydrosulfuric acid. Okay. Here we have H2SO3. And I look at SO3 and I say to myself, self, that's sulfite all day, sulfite. So I have to put us acid, no prefix, no prefix. So SO3 is sulfite, so it's sulfurous acid. NO2 is nitrite, nitrous acid. Okay. Rules for, this is phosphate. Hello, it's an acid. How do I know? Starts with H. And I know phosphate ends with 8, so I have to put ic acid on the end of this name. So this is phosphoric acid. Use the OR for phosphorus. Okay. This is core 8. So then if there's an H in front of it, it's chloric acid. Okay. Look at formulas to names. Right? I'm like, oh look, it's an acid. Hello, acid. Yeah. This is sulfide. So then I have to use hydro sulfuric acid. Yay! Hello! Hello! This is sulfate. So, ic sulfuric acid. Alright, so this is ic acid, but it's a hydro because it was I. Since it was an 8, it's just ic acid. And then hello! Sulfite. This becomes sulfurous acid. Okay. Alright, what if you get an acid in name? How do you recognize it? It says acid right there. So that means we're going to have an H plus, and then ic and hydro came from IDE, so it must have come from nitride. So now we have to make this equal 0. H3N, hydronitric acid. We look at this one and we say ic acid, hello. All right, ic acid came from H, so it came from nitrate, which is NO3 negative, and then you put them together, 1 to 1, HNO3. Us acid, hello, acid. Us came from ite, so it came from NO2 negative, nitrite, NO2, all right, get it, ite. All right, so here's what you gotta do, memorize your ions, do it. Always metals always lose the same number of electrons, so they'll always have the same charge. Group 1 plus 1, 2, all right, memorize those. Roman metals or any other metal besides group 1, 2, aluminum, zinc, silver. Write formulas, cancel charge. Name cation first, Roman numeral, if it's not always the same, and name the anion. Below I'm an acid, use the rules to name and write the formulas. Okay, so we did it all. Hopefully you did it all. And we'll talk about it. Take care. Peace.